Solve. All right, in example A, we have 5 to the x squared plus 8 power is equal to 125 to the 3x power. Our first step is to find the common base for the two terms. So certainly 5 is already pretty basic, so I'm just going to leave that as 5 to the x squared plus 8 power. But for the 125, I know that that's actually 5 to the third, because 5 times 5 is 25, and 5 25s is 125. So I think that that can be written as 5 to the third, and then we have the 3x outside. Then we can multiply these exponents, because we know the rule when you're raising a term to a power, you can multiply the exponents there. So we end up having 5x squared plus 8 is equal to 5 to the 3 times 3, or 9x power. Now, because those bases are the same, we can drop the base and set the exponents equal to one another. So we get x squared plus 8 is equal to 9x. Now, from there, that's quadratic in nature, so that equation can be solved by moving the 9x to the other side, and you'll end up with x squared. If I move this over, it'll become negative 9x plus 8 is equal to 0. And then we'll be looking for what? Factors of 8 that add to 9. So I think we can break that up then into two parentheses. So it'll be x and x. Because it's positive here, it'll be 2 of that sign, so 2 negatives. And then factors of 8 that add to 9, I think those are 1 and 8, right? All right, from there, we can solve these separately to say that what? X is equal to 1 or x is equal to 8. So two solutions. Two numbers that will make that true. All right, let's take a look at B. For example B, we're going to think about the same idea, but we already have common base, right? So the common base here is E. And we just need to remember that when you're multiplying a common base, you add the exponents, correct? So let's put a little plus sign there when we rewrite it. Okay, so let's first do the multiplication of the exponents, right? So it'll be e to the 5x there times e to the x squared is equal to e to the 14th. All right, so when you have a multiplication symbol between two bases that are common, it means that you can keep the base and add the exponents, right? So we're going to have e to the 5x plus x squared is equal to e to the 14th power. And then with that in mind, you can drop the bases and say that we have what? An equation that says 5x plus x squared is equal to 14. And that's quadratic in nature, so let's rewrite it in the proper order. So it'd be x squared plus 5x is equal to 14. Then we can just move this 14 over, making it negative. So x squared plus 5x minus 14 is equal to 0. And then we can factor and solve, if it's factorable, that is. Are there factors of 14 that subtract to give you 5? I think so, right? So x and x, because of the negative here, it'll be a sign of each, plus and minus. And we'll make it 7 and 2, because 7 times 2 is 14, and positive 7 minus 2 is 5x. So our final answer will then be that x is equal to negative 7, and x is equal to 2. When we separate those and solve them separately, we end up with those two solutions. So that's the answer for B, and so it looks like we have two perfectly valid solutions. All right, let's go ahead and look at the last one, which is C. It says, if 3 to the negative x is equal to 1/5, what is 3 to the 2x? Well, in order to solve this, we're basically thinking along the lines of what we thought of before, which is essentially to rewrite the exponent in a useful way. Now, it's a little bit peculiar here because we have this 3 to the negative x, and we're trying to relate that somehow. How does that relate to this idea of 3 to the 2x? Let's try to rewrite the 3 to the 2x so it looks more like 3 to the negative x. I think we could actually do that if we wanted to. So for example, here's how. I can say to myself, well, gee, 3 to the 2x is the same as 3 to the x raised to the second power. I can certainly say that, right? Because I'm just basically bringing the 2 out a little bit. If I re-simplified this, this would go right back to this, right? So I'm kind of expanding it a little bit, you could say. Really just a fancy way to rewrite it, right? And then from there I can say, well, gee, I know if I were to take this 3 to the x over 1 power and reciprocate that fraction, that would certainly change the way it looks, and it would end up being what? 1 over 3 to the negative x, because you know the rule. If this exponent crosses that line, it changes its sign, and you still have the 2 out in front. And the reason why that's useful is because now we have what? We have this 3 to the negative x power. And if that's 3 to the negative x power, and I know that that is 1/5, then I can say, hey, this guy at the bottom has to be 1/5. So I basically have 1 over 1/5 squared. 1 over 1/5 is just what? The same as 1 divided by 1/5 squared, and that's the same as 1 times 5 over 1 squared, or in other words, that's the same as 5 squared. So my final answer for this expression is that 3 to the 2x is the same as 5 squared, which is 25. And that's the final answer.